The first step in factoring a polynomial is looking at the individual terms and finding their greatest common factor. Then we'll see a couple lectures down the road here how we can factor out that greatest common factor once we've figured out what it is. So finding that greatest common factor, that's what we're going to be talking about here. Now finding the greatest common factor of two monomials, like xy cubed z and x squared y to the fourth, like I've got on the right hand side here, is very similar to the process for finding the greatest common factor of two numbers. So what I want to do first, hopefully you're at least a little familiar with that process already. I want to run through an example of that in the middle column here. Then we'll kind of see how those same steps can get me the greatest common factor of those two monomials. All right, so with the numbers 90 and 72, the first step is finding the prime factorization of each number. So 90 is 2 times 3 squared times 5, and 72 is 9 times 8, right? That's 2 cubed times 3 squared. And once I've got those prime factorizations, my next step is to pull out the numbers that the two have in common. Right, so both factorizations have a 2, both factorizations have a 3, but they don't both have a 5. So 5 doesn't make the list, 2 and 3 do. Right, now I'm going to go back to the prime factorizations again, and I'm going to take the smallest exponent for each of the numbers on my list. Right, so looking at the 2, I see there's a 2 to the first and a 2 to the third. So I'm going to stick with 2 to the first. And with the 3s, well, it's a 2 for both of them. So there's a tie, so that's fine. I'm going to use a 2. Then to get my final answer, all I have to do is take all the results from step 3, multiply them together. 2 times 9 is 18. There's my greatest common factor. Okay, now look over at the second column. I want to find the greatest common factor of those two monomials. And I'm going to use a very similar set of steps here. We really don't need to find the prime factorization because, in a sense, the individual monomials are already factored. Right? The factors of the first one are x, y, and z. The factors of the second one are x and y. So I'm going to jump right to step 2 here, and I'm going to list the factors that they have in common. Well, they both have an x, they both have a y, they do not both have a z. Right, so x and y are on my list, but the z is not. Now, again, I'm going to do the same step. Right, the same step as with the numbers. I'm going to take the smallest exponent of each. That's going to be a 1 for the x and a 3 for the y. Then to get my final answer, I'm just going to multiply those together. My greatest common factor is xy cubed. And that's the greatest common factor of those two monomials. All right, so this is just kind of a quick example of how to do this with two monomials. And I'll admit I did keep it a little simple by not putting a constant term, a coefficient out in front. Okay, so one link here will take you to an example where we look at this in a little more detail, where we look at a case where there is a numeric coefficient out in front. And the other link down here, if you want to jump ahead, that link will take you to the next lecture in the series where we start talking about the process for factoring out the greatest common factor.